Good morning, everyone. I'm very glad to introduce our work, FontAnimate, high-quality few-shot font generation via animating font transfer process, a collaboration between the Shenzhen Institutes of Advanced Technology, the Shanghai AI Lab, and the Harbin Institute of Technology. Few-shot font generation, or FFG, aims to create new font images using only a few reference samples of a target style. This task is essential for digital design, multilingual typesetting, and creative content generation, especially for scripts like Chinese that contain tens of thousands of characters. However, existing methods often fail when the target fonts are complex. The generated glyphs may have broken structures or inconsistent styles. We observed that most previous models treat font generation as a static image-to-image problem. But in reality, transferring one font style to another is more like a dynamic transformation, a continuous process. Our main idea is simple but powerful. We reformulate font generation as a video generation task. Imagine the source font image as the first frame and the target font image as the last frame. Then, the font transfer process can be modeled as a smooth video transition from one to the other. This perspective brings three benefits. 1. It provides explicit supervision for every frame instead of only the final result. 2. The inter-frame continuity naturally preserves global character structure. 3. The video diffusion framework enables richer temporal modeling and smoother style transitions. Technically, we build a diffusion-based image-to-video I2V framework extended from an image-to-image baseline. It consists of a VAE encoder-decoder, a content encoder for the character structure, and a style encoder for the target font appearance. To further improve consistency, we design a test-time condition alignment mechanism. This mechanism performs noise inversion on the last frame of the generated video, aligning the output with the given source and style conditions. In other words, it fine-tunes the generative direction dynamically, enhancing both style fidelity and structural accuracy. We built a new Chinese font dataset containing 900 fonts and over 800 characters, and evaluated two test settings: UFSC, unseen fonts but seen contents; UFIC, unseen fonts and unseen contents. Our FontAnimate achieves state-of-the-art performance on all four metrics: RMSE, PSNR, SSIM, and LPIPS, surpassing strong baselines like MXFont, NTF, CF Font, MSD Font, and Font Diffuser. Visually, FontAnimate produces fonts with clearer strokes, smoother curves, and coherent local details, while previous models show artifacts or missing components. Moreover, by viewing the generation process as a video, we can visualize the smooth evolution of each character from source to target, something previous methods cannot offer. In summary, FontAnimate introduces a new perspective. Animating the font transfer process brings motion consistency into few-shot font generation. Our method not only advances FFG performance but also bridges font generation and video diffusion modeling, hinting at broader applications such as animated typography, stylized handwriting synthesis, and cross-domain shape transfer. The limitation is that diffusion-based video modeling is computationally heavier than GAN-based methods. But with recent progress in efficient diffusion and transformer architectures, this cost can be largely reduced.